Today we're talking about solving nonlinear systems. First, a system, we've done them before in chapter 5, is two or more equations. A nonlinear system is a system with at least one of those equations being nonlinear. So quadratics, exponentials, cubics, basically where it's not just a line. So here's an example of what these systems could look like. Now, remember that a solution to a system is the point of intersection, or points of intersection. When we've got a quadratic and a line, or an exponential and a line, we have the potential to have no solutions because there could be no points of intersection, one solution because there could be one point of intersection, or two solutions because there could be 2 points of intersection. Just with linear equations, for nonlinear equations, we can solve them by graphing, by using substitution, or by doing elimination. Same processes we've done before.
Okay, you just heard us talk about how a system could have no solutions, one solutions, or two solutions. Our first step is to solve a nonlinear system by graphing. So I'm asking you to solve that system listed there. In order to solve by graphing, all we're going to do is graph these two equations. I'm going to show you how I graph them in Desmos. So let's go over to Desmos. I'm going to say y is equal to 2x squared was the first part. It says 2x squared plus 5x minus 1 plus 5x minus 1. There is my parabola. One thing that's great about graphing things on Desmos is they'll give you certain points. Like I didn't even touch that. I just hovered over it. There's my 0, my x-intercept. There's 1 over here. There's my y-intercept. Great. To graph the next one, I'm just going to click down here. The next one was x minus 3. So this is y is equal to x minus 3. So one other thing you can see is that Desmos does all of the work for you. Right there, that is the point of intersection, -1, -4. So that is the solution to this system. If I were looking to solve this system right here, I would say -1, -4. Because that's the point of intersection. So again, we took these two, we graphed them on our graphing calculators, we found the point where they intersected, which if you zoom in and move this around a little bit, you can see that that is the clear point of intersection. Wonderful. I'm going to hit this home button over here. Default zoom is what that's called. It just moves my graph back to normal. Okay, let's try the next one. Exit out of both of those. Next one says x squared plus 4x minus 4 and 2x minus 5. Y equals x squared plus 4x minus 4. And it was y is equal to 2x minus 5. I'm going to have to move things around here. Let me just double check that I, put them all in correctly. Good. Okay. We're going to scroll this down here. Find where it intersects, which Desmos gives us the exact specific point. If you just click down here randomly, not that exact point. It tells you the point is -1, -7. So your answer for number 1 would be -1, -7. That's all we need to do for all of these. If you don't have a graphing calculator, then you're going to have to go ahead and graph this quadratic, which you can do by finding the vertex, finding the y-intercept, and graphing it all. Same thing here. This just has a y-intercept of -5 and a slope of 2. We'll do one last one. Let's try this number 3 right here. Y is equal to 3x minus 15. So there's my first equation. I'm going to revert this back home. Y is equal to 3x minus 15. The next equation is y is equal to 1/2 x squared minus 2x minus 7. Oops, gotta go out from there. X squared minus 2x minus 7. So there's my parabola. Again, let me just check my equation. Yep, okay. So I've got my parabola. I can't see anything, so I'm going to zoom out a little bit. And there we go. There are my 2 points of intersection. Here there would be 2 answers. So my 2 answers would be 2, -9 and 8, +9. Both of those would have to be your solutions, and you would have to tell me both of those. Now, there could be a case where there were no solutions. We've had one solution. We've had 2 solutions. Here's a case with no solutions. Those do not intersect, so you would just say no solutions. This is how we solve by graphing.
Now that you've done graphing, we're going to go on to substitution. Now, substitution, think about a sports game. In sports, if we substitute a player, that means we are taking the player out of the game and replacing that player with someone of equal, meaning like we're not taking, most sports, we're not going to take the goalie out of the game and put in a forward. We would exchange a goalie for a goalie, defender for a defender. Same thing with substitution. We're going to take out something and replace it with something of equal value. So here I have y is equal to x squared plus x plus minus 1, and y is equal to negative 2x plus 3. So this is a quadratic that opens up. This is a line with a negative slope. So I could have 0, 1, or 2 solutions. Here's what solving by substitution does. See how this says y is equal to negative 2x plus 3. There is also a y up here that's equal to x squared plus x minus 1. Because y is the same as negative 2x plus 3, I'm going to replace this y with what is equal to negative 2x plus 3. So my first step for substitution is to say instead of y, this is negative 2x plus 3 equals x squared plus x minus 1. Again, the reason being, y was substituted out and I put in what it was equal to. I can solve this now because it's of one variable. Because it's of one variable, we can solve. This is a quadratic, so I'm going to solve it by moving everything to the other side. Plus 2x minus 3 minus 3. So this is 0 equals x squared plus 3x minus 4. I'm looking to solve this now. We just learned all these methods of solving. First off is to try to factor it. Can you think of anything that multiplies to a negative 4 but adds to a positive 3? I can. Minus 1 and x plus 4. Because 4 minus 1 is 3, and negative 1 times positive 4 is negative 4. So we factored it. In order to solve it from here, we're going to set both parentheses equal to 0. So I've got x minus 1 equals 0, and I've got x plus 4 equals 0. That means x is equal to 1, and x is equal to negative 4. So I've got my two solutions. Now I'm not done. Do you see how you said the solution was a point of intersection? X equals is not a point, that's just a letter. In fact, x equals like that is actually a line. I need to find the point, meaning I need to find the y coordinate. So once we've got this, we're going to substitute it back to the equation to solve for y. It doesn't matter which one you choose, so I would choose the easiest one. This is a lot shorter than this one, so we'll plug it into that. So we'll have y is equal to negative 2. Instead of x, we're going to say 1 plus 3. That's negative 2 plus 3, which is 1. When x was negative 4, negative 2 times negative 4 plus 3, 8 plus 3 is 11. Both of those are still not my answers. When x was 1, y was 1, so one of my points of intersection is 1, 1. When x was negative 4, y was 11, so another one of my answers is negative 4, 11. Now, it doesn't matter which equation you plug it into, but if you're going to check it, since you plugged it into the bottom equation, plug these into the top equation to check it. So 1 squared is 1, 1 plus 1 is 2, minus 1 is 1. Negative 4. Negative 4 squared is 16, minus 4 is 12, minus 1 is 11. So those are your 2 points of intersection, or my 2 solutions to the system. Excellent work. Let's try the next one. The next one asks us to solve it again by substitution, so you start with the replacing. This is saying that y is negative 4. So instead of saying y, I'm going to replace it with negative 4. So this is negative 4 is equal to x squared plus 4x. We're going to add the 4 to the other side. 0 equals x squared plus 4x plus 4. I need numbers that multiply to 4 and add to 4. Well, that's x plus 2 and x plus 2. X plus 2 and x plus 2, I'm going to set them both equal to 0. I don't really need to set both of them equal to 0 though, because they're going to be the same. I'll subtract 2, x is equal to negative 2. Now, you're not done. Plug negative 2 in. I don't really have to plug negative 2 in here. See how it says y is negative 4? So that means that no matter what x is, y is negative 4. So the point of intersection has to be negative 2 comma negative 4. This is solving by substitution. Okay, solving by elimination. What solving by elimination was when we got opposite coefficients and added our equations together, and then a certain variable eliminated. That's why we call it elimination. Here, we're always going to try to get our y's to eliminate. So, here's your first equation. Y equals x squared minus 3x minus 2. I also have y equals negative 3x minus 8. Because the coefficients of the y's are the same, all I need to do is multiply that top equation or the bottom equation so that I get opposite coefficients. So let's say that the top equation remains the same. Y equals x squared minus 3x minus 2. In order for these to eliminate, this would have to be a negative y. Because when I add them together, y plus negative y is 0. It's not a negative y, it's a positive y. So what do I have to multiply it by to get to a negative y? Well, negative 1. I can't just multiply one side of the equation or one number by negative 1. I have to multiply every single number by that negative 1. So negative 1 times y is negative y. Negative 1 times negative 3x is positive 3x. And negative 1 times negative 8 is positive 8. So one thing you'll see here though is that I put the 3x so that it was under this negative 3x. That's just going to help me with the next step. Helps me to keep track of my work. So it's called elimination because the y's eliminate. X squared, there's nothing to combine it with. Negative 3x plus 3x is 0x. It just happened that those eliminate. It won't always eliminate. Negative 2 plus 8 is 6. So I have x squared plus 6 equals 0. This is just a quadratic to solve. Let's start solving it. In order to solve this, we need to get the x squared by itself. So I'll subtract the 6 to the other side. Negative 6 equals x squared. Now, let's take the square root of both sides. X equals plus or minus the square root of negative 6. This is not a real answer. Because that's not a real answer, there are no real solutions. There are no points of intersection, meaning that this is a parabola and this is a line that just never intersect. No solutions. That is how elimination works. Let's try one more. I've got y equals x squared plus 2x minus 5. I'm going to leave the top. The next one, it won't eliminate when it's y. It'll eliminate if it's negative y. In order to get negative y, I need to multiply everything by negative 1. Negative 1 times positive 2x is negative 2x. Negative 1 times negative 1 is positive 5. Again, it just so happens that these cancel out. That's not always the case. Y minus y is 0 equals x squared. Negative 5 plus 1 is negative 4. Again, I'm going to solve this using square roots because we have that x squared here. So I'm going to add 4 to the other side, add 4 to the other side. 4 equals x squared, square root on both sides. X equals, I added the square root, so you got to add the plus or minus. The square root of 4 is 2, so this means that x is plus or minus 2. I'm not going to circle that because I'm not done. Solutions are points of intersection, so I've got to find the y. So, my two options are I have x could be 2 or x could be negative 2. I'm going to use the bottom equation, y equals 2x minus 1, because it's less steps. Let's plug in 2. 2 times 2 minus 1 is 4 minus 1. which is 3. So when x is 2, y is 3. Plug in negative 2. 2 times negative 2 minus 1. That's negative 4 minus 1. That's negative 5. We have 2 comma 3 is one solution, and negative 2 comma negative 5 is another solution. So this one happened to have 2 solutions. This one had no solutions. This is how we use elimination. These are just a bunch more practice problems we're going to try right now to make sure we know it all. One thing to be careful of is it really doesn't matter what method you choose. Substitution and elimination both will work every time, which is different than some of the other ones we've done. So will graphing. It's really just, eventually you're just going to need to decide which one you like to do more. I'm going to start with this one, and I'm going to do substitution, just to practice substitution. Remember, substitution says if y is negative 5x, replace it in the next equation. So negative 5x equals x squared minus 3x minus 3. I'm going to solve this, which means I need to solve a quadratic, I have to get equals 0 on this side. So I'm going to add 5x and add 5x. So 0 equals x squared plus 2x minus 3. Again, in order to solve a quadratic, you've got tons of different methods. If you felt like it here, complete the square. Go for it. I'm going to try to factor. I'm looking for things that multiply to a negative 3, but add to a positive 2. Well, that's 3 and negative 1. So this factors as x plus 3, x minus 1. Set both parentheses equal to 0, x plus 3 equals 0, x minus 1 equals 0. So x equals negative 3 and x equals 1. Again, we're not going to circle that answer yet because it's the point of intersection. You've got to find the y. So plug it in. Negative 3 times negative 5 is positive 15. So one of my answers is negative 3 comma positive 15. Plug in 1. 1 times negative 5 is negative 5. My two answers there, or my points of intersection, are negative 3 comma 15 and 1 comma negative 5. For the next one, I want you to try solving this one by yourself, and then check with my answers right here. You should get no solutions. Okay, we're going to try elimination for this one. Now, they're not going to eliminate right away because this is y and y. But if this were just a regular y equals x squared plus x, if this were negative y, they would eliminate. So I'm going to multiply every single number by a negative 1. So that's negative x and negative 5. Now when I add those together, I get 0 equals x squared minus 5. You'll add 5 to both sides. 5 equals x squared. Take the square root. X is equal to plus or minus the square root of 5. The square root of 5 is about 2.24. So I've got my x coordinate could be 2.24 or negative 2.24. If it's 2.24, add 5, you get 7.24 as one of your coordinates. So 2.24 comma 7.24. If it's negative 2.24, negative 2.24 plus 5 is about 2.76. So there are your two answers. Let's try one last elimination one. I ran out of room, so I'm going to write it underneath. I'm going to keep this bottom equation, y equals negative 3x squared plus x minus 4, just because it's longer. In order for it to eliminate, the top equation would have to be negative y, so I'm multiplying all of those by negative 1. So that's negative 2x and negative 5. If you add those together, you get 0 equals 3x squared minus x minus 9. We're going to again try the quadratic formula to solve this one. A is negative 3, B is negative 1, and C is negative 9. X is equal to the opposite of B plus or minus B squared, which is 1, minus 4 times A is negative 3 times C is negative 9 all over 2A. That's negative 6 in the denominator, 1 plus or minus the square root of. 4 times 3 is 12. 12 times 9 is 108. It's negative, so 1 minus 108 is the negative square root of 107. I cannot take the square root of a negative number, so this one also has no solutions. Now, the no solutions had nothing to do with the fact that we needed to use the quadratic formula. It just had to do with the fact that when you got the square root, you had gotten a negative number. Taking the square root of a negative number means that there are no solutions. This is solving nonlinear systems.